Hello guys, how are you? Welcome back to Math Zone African Motives. We are back at it again, and we have now started our revision for our November exams. We are now preparing for our November exams. So today I brought you a question paper from the Gauteng province, and this question paper was for grade 11s, which was physical sciences, paper 1, which is physics part. So you would see that in your final exams, you would be having a full paper for paper 1 that will be out of 150 marks, and you're supposed to write it in 3 hours. And you're also going to have paper 2, which will be also having 150 marks, which will be written in what? In 3 hours as well. So let's start our revision and let's actually start practicing. So let's get started and see what is, or else what was this question paper made of. So you would see that from our question paper or from our question papers, you would be given multiple choice out of 10 questions. That would be housing 20 marks. So out of each question, you would be having 2 marks, and you'll be given 4 options to choose from, which is to choose either A, B, C, or D. And you only have one correct answer. You only have what? One correct answer is stated there. So you need to choose the most accurate answer. So here they're saying the statements below refer to vector and scalar quantities. A vector has magnitude and direction, while a scalar quantity has magnitude only. So this is true. This statement is true. A scalar quantity can always be added to a vector quantity. This is false. We cannot add a scalar to a vector. We can only add a scalar to a scalar, a vector to a vector. Force is an example of a vector quantity, while distance is an example of a scalar quantity. That is actually true. Which of the above statements is or are true? We only have got statement number 1 and statement number 3 being true. So our correct answer there was going to be B. Now question number 1.2. A learner pushes 2 blocks, which is block A and B as shown on the diagram, across a rough horizontal surface at constant velocity. The mass of block A is less than that of block B. How does force F1 that block A exerts on block B compare in magnitude with force F2 that block B exerts on block A? So we know that according to Newton's third law, whenever an object is in interaction with another object, let's say object A interacts with object B, object A is said to exert an equal and opposite force to the force that will be exerted simultaneously by B. So we know that force 1 is supposed to be equal to force 2, but in the negative direction. So now they're saying, how will the magnitudes compare? So the magnitude of F1 will simply be equal to the magnitude of what? Of F2. But these two, they are not supposed to be equal to 0. So the two magnitudes will be equal, but they are not supposed to be equal to what? To 0. So our correct answer there was going to be A. Now going to 1.3. Two forces F1 and F2 act on a point. If F1 and F2 act in the same direction, the maximum resultant is a magnitude of 15. So we have got F1 acting on a point, and also F2 may be acting on that point in the same direction. And they are saying that the resultant, which we know that it will be given by the sum of the two, since they are all in the same direction, it will be F1 plus F2, is given to be equal to 15 newtons. And then now they're saying if forces F1 and F2 act in opposite directions, the magnitude of the minimum resultant is 3 newtons. The magnitude of the two forces in newtons is going to be what? So we now want to find the magnitude of each. So they're now saying that if now F1 acts in the opposite direction as F2, the resultant of these two, which is given by the sum, but now they're in opposite direction, I would take going to the right being positive. I would have F2 minus F1 is equal to 3 newtons. So now you would have formed equation 2 and equation 1. If you take them to say F1 plus F2 is equals to 15, which is equation 1. And then you actually get to take F2 minus F1 to be equal to 3 Newton, which is equation 2. You can actually decide to make, let's make F2 the subject here. F2 would be equal to 3 plus F1. That is for equation 2. So now I'm going to actually substitute equation 2. I will substitute equation 2 into equation 1. By doing that, I would have what? I would have F1 plus my F2 is now equal to 3 plus F1 being equal to what? Being equal to 15. So that F1 plus F1, it will be 2F1 being equal to, I would transpose 3, it will be 15 minus 3. So this is equal to 12, and this is 2F1. I divide by 2, I divide by 2. My F1 would be equal to 6. If I say 2 into 12, it is going to give me what? It is going to give me 6. So when I now know F1, I can now know F2. So F2 would be equal to 3 plus 6, which is just equal to 9. So I now have got 9 and 6. So the correct answer there was going to be D. The correct answer was going to be D. Now, question number 1.4. The gravitational acceleration on a planet twice the mass of Earth and half the radius of Earth would be. So they want you to find the gravitational acceleration on a certain planet, let's say planet A, when that planet is having its mass being equal to 2 times the mass of the planet of the Earth, the radius of planet A being half of the radius of the planet Earth. So we know that calculating, let's use Newton's what? Let's use Newton's universal gravitational law, which says that F is equal to G, mass of an object, times mass of the what? Of the Earth, divided by R, which is radius of the Earth squared. That would actually get to give you mg, where this is mass of the object, mass of the object. So the gravitational acceleration on Earth would actually be equal to what? It would actually, Ge would actually be equal to G, mass of the Earth all over radius of the Earth squared. If that is the case, what would become the gravitational acceleration on planet A? So I can now also come and say gravitational acceleration on planet A can be given by G, which is a constant, and mass of the planet A over radius of planet A squared. Where if I substitute in terms of this, because I already know this value, which is equal to 9.8 meters per square second, because here they want us to give it in what? In terms of a certain value. So we know this value, so we can find gravitational acceleration on planet A in terms of the value of what? Of gravitational acceleration on planet Earth. So now I would say this is G, and then I would multiply by this mass, which is 2 times mass of planet A, all over this radius, which is half RE, and then I'll square. So you would see that at the end of the day here, I would be having 2G ME all over, I've got 1 over 4 RE squared. So this is now the gravitational acceleration that I know, which is due to the what? To the planet of Earth, which is equal to 9.8. So here I would be having, if I invert 1 over 4, I would be left with 4 times 2. That is 8 times G, which is gravitational acceleration on planet Earth, which is 8 times 9.8. If I say 8 times 9.8, I'm supposed to get 78.4 meters per square second. So the correct answer there was going to be D. The correct answer there was just going to be D. So that is how we apply our laws to solve and actually get what? To choose our options there. Now let's go to question number 1.5. Now question number 1.5, it is saying The diagram below represents the electric field pattern around a negative point charge. Now they're saying R, S, and T are points at different distances from the negative point charge. Now we are saying that we have got this negative point charge and they want us to find what? They are saying the magnitude of the electric field of the point charge is what? Is it going to be greatest on point R? Is it going to be greatest on point S? Is it going to be greatest on point T? What governs the electric field? So we know that electric field is given by KQ, which is the charge that is here, divided by R squared, where this R squared becomes the distance from this point charge. It becomes the distance from that point charge. So we can actually get to see that the smaller the distance, the smaller the distance, the greater the what? The electric field force. The electric field force, it is actually going to have a greater attraction or else repulsion here. That is what we mean by electric field. This is the region where you would experience some force. So we are now getting to say, we are now looking for which distance is smaller. Is it T to this or else S to that? So you can see that T has got a what? A smaller distance away from the negative point charge. So the electric field was going to be greater at point T. So it is going to be greatest at point T, meaning to say point T is going to experience a greater electric field force. That is what it means. Now let's go to 1.6. Now let's go to 1.6. Two identical conducting spheres that have positive charges Q1 and Q2, where Q2 is having double the charge of Q1. So positive charges, we have got Q1 and then Q2, and Q2 has got 2 times the charge in what? In charge Q1. Now they're saying they are separated by a distance of R, so the distance in between these two is R. If they are made to touch each other and they are separated to the same distance, the force between them would be what? So we need to calculate the two different forces. We've got force 1, where we are saying that it will be given by K Q1 times Q2 all over the distance, which is R squared. But we know that Q2 is actually carrying 2 times the charge that is in Q1. So we can actually get to have it in this form so that it becomes 2 times Q1 squared all over R squared, where we are saying that we are going to square the charge that is in what? In positive charges of Q1. And then now, when we are now looking for F2, now since they say that when they touch, the net charge that we are going to have on each, it is going to be Q1 plus 2Q1 all over what? All over 2, where we would have added Q1 plus Q2 and divided by 2. So since Q2 is 2 times Q1, we are going to do this. So this one is going to give us 3Q1 all over 2. That becomes the net charge on each after separation. So F2 is going to be Q3 over 2 Q1 times 3 over 2 Q1 all over R squared. And then we can see that this would fall to what? To 6 over 4 K Q1 squared all over R squared, which will fall to 3 over 2 K Q1 squared all over R squared. Now we want to compare F1 and F2. You can see that 2 is greater than 3 over 2. So F1 would be greater than what? F2. So the answer there would be to say that our force now will now be smaller than it was before, because we are saying F2 is smaller than what? F2 is smaller than F1, or else F1 is greater than what? F2. So we can say that F2 is smaller than F1. So our force now, the force between them will be smaller than before. That is C. Let's go to question number 1.7. Question number 1.7 is saying, which of the following will give the most effective, strongest electromagnet? the one that will give us the strongest electromagnet. Is it a single wire with a high current flowing through it? Yes, we need to have a high current flowing through it, but we need to have many wires or else many turns. We need to have many coils or else many what? Many turns. So we are looking for many turns of wire and then with a high current. So our option was going to be D, many turns of wire in a coil with a high current flowing through the coil. That was going to be our answer for 1.7. Now let's go to 1.8. You would see that the diagram below shows a magnet that is being moved away from the solenoid. So the magnet is being moved away from the solenoid, and then they are saying which one of the following statements is correct. The induced current will flow from A to B as it moves through the resistor. So we need to know how is the induced current going to flow through the resistor. So we need to understand what's happening here. So according to the Faraday's law, we know that an EMF is going to be induced whenever we are having a change in flux linkage. Whenever we're having a change in flux linkage. And that EMF is in the opposite direction to whatsoever is causing it. It is in the opposite direction to this change of the magnetic flux. So now you can see that when the magnet is moving away from the solenoid, what is going to occur here is the magnetic field is going to decrease. So the magnetic field is going to what? Or else let's say the magnetic flux is going to decrease. Here we are going to say the magnetic flux or magnetic field flux or linkage is going to what? Is going to decrease due to the what? To the moving away of this what? Of this magnet. If that is the case, this solenoid will now get to act in such a way that it has to actually reduce this decrease. So if it has to reduce this decrease, we need to bring back the polarity that we are losing here. So the polarity that we are losing is actually what? The north pole. So we need to have a south pole here so that it can attract back this north pole. When it attracts back this north pole, it simply means that here we are going to have a north pole. So by using the right hand solenoid rule, we can actually have our thumb pointing towards the north. We can actually have our thumb pointing towards the what? The north. When it points towards the north, then you would see that your fingers would be curling anti-clockwise. Then the direction of those fingers, it represents the direction of the what? Of the current. So the current would be flowing in an anti-clockwise direction. When it flows in an anti-clockwise direction, it means that it will flow from B to what? To A across this resistor. So that is the answer that we are looking for. So we are saying that the induced current will flow from B to A as it moves through the resistor. So the answer there was going to be B. The answer there was going to be B. Question number 1.9. The circuit diagram represented below contains two resistors and three identical ammeters, registering readings I1, I2, and I3 respectively. So you can see that we have got this ammeter 1, ammeter 3, and ammeter 2. So now they're saying which one of the following statements is actually what? Which one of the following statements is actually incorrect? So now the first statement is saying I2 is equals to I1 plus I3. We can see that current is moving from this positive through this. So I2 becomes our total current, where this one is a junction. So this is a parallel circuit. So that is going to be equal to what? I1 plus I3. So this is actually true, or else this is correct. And then now I1 is less than I3. I1 is less than I3. But we can see that the current here is passing through 5 ohms, whilst the current here is passing through 6 ohms. So the tendency of the current is to move past through a smaller resistor. It's more like when you are trying to exit a mall. When you're trying to exit a mall, you would actually get to choose where there is a wider opening, or else more people would go through a wider opening other than a narrow opening or else a narrow door. So we are saying that current usually chooses the what? The easiest path to follow. The easiest path to follow. So the easiest path to follow is the one that is having lesser resistance. So we are going to say I1 will be greater than what? I3, because here we have got what? Because we are saying that resistor 1 is actually what? Smaller than resistor 3. So this is actually what? This is actually incorrect. This is incorrect. And then I2 is the current in the cell. Yes, I2 is the total current. It is the current in the cell. This is true, which is correct. And then I3 is the current in the resistor 6 ohm resistor. Yes, this is correct as well. This is correct. So the only incorrect answer there was going to be B. The only incorrect answer there was going to be what? It was going to be B. If that is the case now, let's go to 1.10, which becomes the last question on our multiple choice questions. So now we are now saying the meaning of a potential difference of 15 volts is. What is the meaning of a potential difference of 15 volts? So we know that the potential difference, what is the potential difference? How do you define potential difference? We know that potential difference, it is energy dissipated or energy carried to a unit what? Charge. So energy dissipated per unit charge. Energy dissipated per unit charge. So this would actually be what? 15 joules per unit what? Per unit coulomb. Or else 15 joules carried or else dissipated to a unit charge. So we are looking for that answer. When a current of 5 amps flows through a circuit with a resistor of 3 ohms, someone using the Ohm's law would actually get to say this is correct because this would be 5 times 3 ohm and this would give you what? 15 volts. But that is not the definition of potential difference. This is just how you would calculate voltage according to the Ohm's law. That's not the definition. So this might to some extent be true by calculations, but this is not the definition of what potential difference means. When 15 joules of energy is delivered to each coulomb of charge traveling in the circuit, this is the correct answer. Where 15 joules of energy is delivered per each coulomb of charge traveling in the circuit. That is what we are looking for. Now let's go to our open-ended questions. So now we are now doing question number 2. We have now started open-ended questions. Now we are saying, consider the 3 forces acting on an object as shown in the diagram below. We've got this T force, and then this W force, and that force. And then they are saying, define the resultant vector. We know that the resultant vector becomes, so the resultant vector is the single force. The resultant vector becomes the single force, or else the single vector. The single vector is the single vector that we will have the same effect, as the sum of the individual vectors, as the sum of the individual vectors. Here, the vectors that we are referring to are the forces. So the resultant there would be having the same effect as the sum of the 3 forces that are there. If we get to sum them considering that direction, the resultant would be having the same effect as these 3. That is what the term resultant of a vector means. It is a single vector that will have the same effect as the sum of the individual vectors. Now they are saying, determine the magnitude and direction of the resultant of the horizontal component and the vertical component. So we now need to resolve these into vertical and horizontal component. So we now need to resolve this into vertical and horizontal component. So we know that if a vector is acting at a point which is at an angle, we need to resolve it into what? into vertical component, which is acting along that vertical component, and then into its what? Horizontal component. So this would be, let's get to say horizontal component of T and vertical component of T. And then we need to also get to resolve that into vertical component of F and horizontal component of what? Of F. And then W is already in its vertical component. It has no horizontal component. Now, after doing that, we need to find the sum that is, we need to find the resultant in the X direction, which is the horizontal component. And then we need to find the resultant that is acting in the Y plane, which is the vertical component resultant. So that is what they mean there. So how do we actually get to do that? So one thing that we can do, we know that for the vertical component would actually be given by what? The vertical component would be given by our hypotenuse, this one, which is our force. So it will be F sine theta, while the horizontal component will be given by F cos theta. So if we resolve this into horizontal, it will be F cos theta, where the force is this, and then this one will be F sine theta. So here we are going to have force 1, which is actually on the x-axis. It will be the horizontal component of T. So here we are going to have horizontal component of T plus horizontal component of what? Of F. But now these are in two different directions. So we need to choose the one that we call positive and the one that we call negative. So let's choose going to the right to be positive. Let's just get to choose going to the right to be positive. So let me just get to show you how you would have just resolve those, and then you can be able to sum them. So here I would have just came here and have this one would be F sine 20, and then this one would be F cos 20, and then this one would actually come and be T sine 45, and this one would be T cos 45. So I now have got this horizontal component going that side and that one going that side. So if I choose the right to be positive, I would have on my Rx on the horizontal component, where I'm now looking for the horizontal component, I'll come and say this one is positive. That would be 250, 250 cos 45 minus this one, which is 150, 150 cos 20. So the resultant there would actually be equal to what? So if you actually come and say 250 cos 45, you are going to have 250 cos 45 minus 150 cos 45. So on your x-axis, you would be having a resultant of what? You will now be having a resultant of 35.83. This would be 35.83 newtons. That is on your horizontal component. And then on your vertical component, which is your y plane, you would be now having these ones going up, and then you are having this one going down. So you can actually get to choose going up to be positive, so that you can have F sine 20, it will be actually 150 sine 20 plus 250 sine 45 minus this 100. And then if you do that, you are supposed to find a resultant vector on your y plane simply being equal to 128, 128.08 newtons. That is the resultant on the horizontal, resultant on the vertical. That is what you are just supposed to do there. By doing that now, they are now saying determine the magnitude and direction of the resultant force acting on the object. Now, since we said that positive is going to the right, this is actually towards the right. So here you would actually have your 130, your 35.83 going to the right, or else to the right, and then this one would actually be what? Going up. So this one would be going up. So this one would be going what? Up. Because we chose up to be positive. So if that is the case now, they now want the resultant of these two. The resultant of these two. The resultant that would actually act upon those. So the resultant here, since we are saying that we have got a force that is going what? It is going to the right. So here we have got a force that is going to the right. And then we've got a force that is also going what? Up. So a force that is going to the right, it's 35.83. The one that is going up, it's 128.08. And then we want the resultant. So at some point in time, if that is the case, we would want the resultant of these two. So I would actually have to draw my diagram in such a way that we can use head to tail to find the what? The resultant. So this one is going that side, and this one is going that side, and then our resultant would be in this format where this is theta, where this is theta. So this would be our total resultant, where this would be resultant of the y plane, and then this one would be resultant of the x plane. Because the resultant of the x plane is going to the right, the resultant of the y plane is going up. So by head to tail, we would actually say we start at the tail of the first and go to the what? To the head of the what? Of the last. So that becomes, so having that, we now have got a right angle triangle. From a right angle triangle, we can use what? The Pythagoras theorem to find r by saying r squared is equals to rx squared plus ry squared. So that is what we are going to simply do there to find the magnitude of the what? The magnitude of the resultant. So that being the case, let's substitute our values. So r squared would simply be equal to 35.83 bracket squared plus we have got 128.08 bracket squared. And then we would actually get to root and root everything. After rooting there, we are supposed to find an r that is equal to, so let's punch in our calculators and let's find the resultant there. So you would see that you are going to get 132.899. So after rounding off, you are going to get 133 newtons. After rounding off, the resultant there is going to be 133 newtons. You are going to find 132.899. So if you round off, you just get to give what? 133 newtons. That being the case, we know that this is a vector. It has to have direction. So the direction is going to be given by that theta. So by finding this theta, you would have just found that direction. So how do we find theta now? So we know that from Chasho tau, tan theta is equal to what? Opposite over adjacent. We are using this Chasho tau. So we know that tan theta is equals to opposite over adjacent. So what is our opposite? That is ry all over what is our adjacent? That is rx. So we can say tan theta is equals to ry over rx. So that theta would definitely be arctan. Ry is what? Ry, we have got ry being 128.08 divided by 35 point what? We said it's 35.83. So that our theta would actually be equal to what? So you would see that after doing that, you would find that your theta would actually be equal to 74.37 degrees. 74.37 degrees. That is the answer that you are going to find there. So that is the magnitude and direction of the what? Of the resultant vector that is actually acting on the object. Now they're saying give the magnitude and bearing of the force that can balance the system. So since now we have said that the resultant is actually in this format, to say that we have got a force in that direction and then we have got a force in that direction, and we said our resultant would be in this direction, which is theta there. So our resultant going in that direction, if we are to draw a bearing, like we have said, if we are to draw just our compass there so that we can actually use the bearing, to actually find the balancing force. We can see that a balancing force to a force that is going in that direction would be an equivalent force that is actually also in that same opposite direction, which would be going in that direction. So this would actually become the equilibriant, which is actually what? The balancing force. So our equilibriant, its direction would be given by theta here. So the equilibriant here would simply be actually that same force, which is 133 what? 133 newtons. But in the direction of what? Using the bearing, we start from here going to the direction. So you can see that from here to here is a straight line. So this is 180. 180 plus theta, which is 74.3. It will give you what? It will give you what? Your theta would actually be equal to 254.37. So we are saying that we have got this force being our equilibriant and being in that direction using the what? Using the bearing. So it will actually be from here going to there. So this means that you have to move from the east going anti-clockwise to actually have what? 250.37 degrees. That is what you were just going to say there. So at some point in time, you would actually come and say 2.4 when you're answering. It would actually get to say E would be equal to 133 newtons at a bearing of 254.37 degrees. That is what you just have to do there. Now let's go to question number 3. Now question number 3 is now saying that national building regulations for trolley and wheelchair ramps specify that a ramp must be 6 meters in length, while the angle of the ramp must be 4.76. The combined mass of the trolley and its contents are 80 kgs. The coefficient of the static friction between the wheels of the trolley and the ramp is 0.1. So this is our coefficient of what? Static friction. Now they are saying define the static frictional force. So static frictional force is the opposing force of motion on a stationary object. So that opposing force to motion or else of motion on a stationary object that acts on a stationary object becomes our what? Our static frictional force. Now they are now saying they want us to draw a labeled free body diagram of all the forces that are acting here. So we can see that the forces that are actually acting here, we have got the weight, and then we would actually have the what? The static frictional force, because they say that just as it starts to roll down the ramp, so the static frictional force would be in that direction because it is opposing that that motion that wants to occur of rolling down. And then rolling down here, this would be due to this FG parallel, where we say it is the component of this weight in the parallel direction. And then we are also going to have a normal force that is actually going to what? To balance there. We are actually going to have what? A normal force that would actually be balancing the parallel weight component. So drawing a free body diagram, you would actually get to come and have it in this format. So let me draw the free body diagram aside. So I would represent that object with the dot, and then I will say that going down here, I would be having its weight. And then I would be having a frictional force that is going to act in that direction, which is the static frictional force. And then I'm also going to have the what? The normal that is balancing a perpendicular what? That is balancing the perpendicular component of the weight. So that is going to be my normal force. So that was the diagram that you could have drawn. Others, they would prefer to draw it in such a way that they will be having static frictional force, and then they will be having the normal force there. And then after having that normal force, they would actually come and resolve the weight into its component, which is Fg parallel, and then they would also have Fg perpendicular to that. So this would be Fg perpendicular like that. So they will resolve it in such a way. But however, the number of marks should guide us into how many forces you are supposed to represent on that diagram. So here we're having 3 marks. You are just supposed to show 3 forces. That is what you are just supposed to show there. We're just having 3 marks and you're supposed to show 3 forces. Now they're saying if the ramp is longer than 6 meters, uh, sorry, I skipped this. They said while the trolley is at the top of the ramp, calculate the magnitude of the maximum force of the static friction. The maximum force of the static friction is actually given by the coefficient of the static friction times the normal force, where we know that the normal force would be balanced by the what? By the weight perpendicular component, where this weight perpendicular component is just mg cos theta, where theta is 4.76. So this is got to be 80 kgs times 9.8 cos of 4.76. So that was going to be what? That was going to be equal to, if you say 80 times 9.8, 80 times 9.8 cos 4.75. So here we're going to say 0.1 times this. That is our normal force. That would be 80 times 9.8 cos of what? 4.76. So that uh, the total static frictional force would simply be equal to what? To 78.13 newtons. That is the answer that you're supposed to find. So if you use your calculators, if you come here and then you say later, this is going to be 0.1 times Fn, where this is your Fn, you would find that answer. You would actually get to find that answer. If that is the case now let's see what are the questions that are coming. So allow me to rub on top there as well as here. So you were just supposed to say Fs is equals to 0.1 times 80 times 9.8 times cos 4.76, and that will give you 78.13 newtons. Now they are saying if the ramp is longer than 6 meters, a less steep gradient is required. For a ramp of less steep gradient, state whether the following would increase, decrease, or remain the same. The coefficient of static friction. So the coefficient of static friction is only affected by the roughness of the surface. It's only affected by the surface. So it is only affected by the property of the surface. So this would actually get to remain the what? It would actually get to remain the same. It will remain the same. So this will remain the same since it is not affected by the steepness of that ramp. It is only affected by what? By the properties of the surface. Now, what about the force of static friction? The force of static friction, we saw that this is given by the kinetic coefficient of friction, and then times what? Times the static coefficient of friction times the normal force. So if this remains the same, this is going to change. Why? Because that is given by what? By mg cos theta. We saw that Fn will be given by mg cos theta. So as this angle is changing, this will also change. Now they are saying that initially we were having a what? A steeper gradient. So mean to say that we're having theta 1, and then now we are now having a what? A less steeper gradient. That is now theta 2. So you can see that since theta 2 is actually what? It's actually smaller than theta 1. We know that according to cos, the smaller this angle, the greater the magnitude. So the magnitude of the normal force here is going to increase as this angle is decreasing. So if we decrease the steepness, the normal force is going to increase. Therefore, the static frictional force is also going to what? It's also going to increase, because they say that if the ramp is longer than 6 meters, a less steeper gradient is required. So it means that the angle there is going to be smaller. Now they're saying explain the answer to question 3.42 in scientific terms. We say that we are just simply saying that as the angle decreases, so you'd actually get to say that the as the angle of incline decreases, the normal force increases. The normal force increases. As the coefficient of friction remains the same, or friction remains the same, as it is remaining the same, remains the same. Therefore, the frictional force, or else the static friction, will increase. As the normal force is increasing, the static frictional force will also get to what? To increase. That is what we are just supposed to say there. That is the explanation in what? In scientific terms. Now they are now saying that learners in the physical sciences laboratory, they perform an experiment with a trolley and a wooden block on a ramp. The main aim of this experiment is to compare the kinetic friction to static friction by plotting the values of the two experiments on the same set of axes. These are the values that they found. So they are saying that they recorded these values that are given here. After recording those values, now they are saying use the information in the table to plot a graph of both the trolley and the block on the same set of axes. Label the graph on the trolley as A and the graph on the block as B. So they want you to use those values to plot a graph. So they are saying that you have to label the graph of the trolley as A and as B. So we know that the graph of friction, the graph of frictional force, it would be to say frictional force against normal force. So it would be your frictional force, which is here they said static frictional force, against the what? The normal force. So we are saying that the independent variable there would be the normal force, where your static frictional force would depend on the what? On the applied or else on the normal force. Now we are now drawing that. So the normal for A against the what? The static frictional force for what? For A. So here we have got 1, 2, 3 values. So let's just get to say here we are starting at what? 6.8, 7.75, and 8.7. So I can actually get to come. So I'm going to use a sketch and later show you the actual graph. So here for your normal, you're just supposed to, let's say, you're going to say, let it be, let's say 2, and then let it be 4, and or else, yes, and then let it be 6, and then let it be 8. And then this one would be 10. And then this side, we've got 0.185 to 0.2. So I would say, let this one be 0.1 and let this one be what? 0.2. After that, I would also get to say, let that one be 0.3. If that is the case, I would start plotting my values there. So plotting my values, I would take 6.80 against 0.185, 6.80. So this can be 7, and then 6.80 can be here. So if I take 6.80 up, and then I would need to plot against 0.8185. So it can actually be here, so that wheresoever these two lines meet, like for example here, this becomes my plot. The second plot, so we have plotted this first plot. The second plot is 7.75 against 0.21. So 7 can be here, and then 7.75 can actually be here. If that is the case, I'll take this 7.75 upwards. I'll take it upwards like that so that I can be able to say against what? 0.21. This is 0.2, and then 0.21 can actually be what? 0.21 can actually be here. If that is the case, where these two meet, that is where I'm going to have my second point. My third point is 8.0 and 0.235. 8.70, this can be 9, so 8.70 can be here. So let me say 8.70 can be here. So if you were having a graph paper, you would actually get to count the number of boxes that would be in corresponding to what? To 8.7. And then you would also count the boxes that would be in corresponding to what? 0.235. This can be here. 0.235. So my third point would be here. Now drawing this graph, I would actually get to join these points coming from what? From 0 there. So it was just going to be a straight line. It was just going to be a straight line. So this is for what? This is for graph A. And then for graph B, you would also come and do the same thing. For graph B, you would also come and do the same thing. This normal against that. 6.80, this is 6.80 against what? 0.15. So maybe 0.15 would actually be here. 0.15. And then against this, 0.15. And then 7.75, which is this one, against what? 0.17. So 0.17 can actually be here. 0.17. So this point, that is what I'm looking for. And then I go to 0.19. 0.19 can actually be here. 0.19. And then 0.19 is against what? 8.8, like that. And then I would also need to what? To plot again this graph. And that was also going to be a smooth straight line. So that being the case, this graph would be for A, this graph would be for B. And then we can actually get to follow the next questions. So that is what they wanted you to do there. That is what they wanted you to do there. So let me just get to show you the graph that they drew themselves. The graph that they drew themselves. So you would actually get to see that the graph that they drew themselves is just equal. This is the graph. So they said we are having the frictional force being this side, and then we're having the normal force being that side. So that is what they drew there. So let me just get to say, so here they said 0, 1, 2, 3, 4, 5, 6, 8, 9. And then you can see that they plotted these. So this is for B, this is for A. So you can see that we are having a what? A smooth straight line there, a smooth straight line there. So you just need to draw a line of best fit. So after that, let's hear what are the next questions saying. What are the next questions saying? So let's get to hear what are the next questions saying. So now we are now looking for what? For question number, they are saying, let me just get to use it like this. Which part of each of the graphs represents the coefficient of friction? Which part of each of the graph represents the coefficient of friction? From these graphs, which part represents the coefficient of friction? You can see that the coefficient of friction, from its definition, mu s can be given by what? By force, frictional force Fs divided by the normal force. So if we divide this frictional force by the normal force, we are actually looking at what? We are actually looking at the gradient. So you would have just came and said the gradient of the graph, the gradient of the what? Of the graph. So there you are just supposed to say gradient of the graph, gradient of the graphs, gradient of the graphs. That is what you are just supposed to write there. The gradient of the what? Of the graphs. I just want to write my G in a way that it does not affect the next question. So now they're saying if the graph of the trolley represents static friction and the graph of the block represents kinetic friction. So if this represents static friction and this represents what? Kinetic friction. Explain the difference between the coefficient of static friction and the coefficient of kinetic friction that can be observed from the graph. So from the graph, you can see that this graph is having a steeper gradient than this graph. So you can see that gradient of A that we can represent by MA is greater than gradient of what? Of B. So that mu of A would be greater than what? Mu of B. So the static frictional force, the static coefficient of friction would be greater than the kinetic friction, the kinetic what? The kinetic friction. So we are saying that the coefficient of static friction will be greater than the coefficient of the kinetic friction from the two gradients, because you would actually get to say because gradient of A is greater than what? Gradient of B. That is what we have said there. Gradient of A is greater than gradient of B. Now let's go to question number 4. Let's go to question number 4. Question number 4 is saying a buggy stops at a crossing. The driver of the buggy suddenly pulls away. A person sitting at the back of the buggy falls off. Imagine this car stops and then after stopping, the car actually drives away. I'm sure in a fast, or else it just pulls away fast, suddenly, fast. It so now you would see that the effect of that is that the person who would be sitting at the back can actually get to fall off. Why is that? Because of what we refer to as inertia of the person. That is the tendency to resist the state of motion, because that person was just seated there and then now the car is just driving off suddenly, so his mass will resist that forward motion. So because the mass is resisting that forward motion, he will be left seated in air. That's the reason why he would fall off. Now they're saying identify the law that will cause the person to fall off the back of the bag. That is Newton's first law. That is Newton's first law. They wanted us to just identify that law. They didn't want us to explain anything, but I've given the explanation. So Newton's first law is the law that has to do with what? With the inertia of a body. And that inertia of the body is due to the mass of that body. Now they're saying name the property of matter that will determine the inertia of an object. That is the mass. The mass determines the inertia of an object. Give an example of a safety precaution. Give an example of a safety precaution that is used in motor vehicles to prevent such an accident. We have got what we refer to as what? Seat belts. That is their main purpose, to actually get to prevent this accident. Now we are saying, what should the net force of a man of 70 kgs be if he sits inside the vehicle and moves at a constant velocity of 15 meters per second? Once you hear the word constant velocity and they're asking about the net force, just know that acceleration is 0. Therefore, the net force, as it is given by that law, which is the second Newton's second law, it is also equal to what? To 0. So the net force here would be equal to 0. So you would say net force is equal to 0 because the object is moving at a what? At a constant velocity. Once the object is moving at a constant velocity, there is no net acceleration. Hence, therefore, there is no net force. Now let's go to question number 5. Question number 5. Now you might actually get to see that question number 5 is coming from 5.1 up until to 5.7. So question number 5 is saying two blocks A and B are tied to each other by means of a light inextensible string as indicated in the diagram below. Block A has a mass of 10 kg and experiences a frictional force of 29.88 newtons. Block B has a mass of 8 kgs. The coefficient of kinetic friction of the rough incline is 0.31. A force F moves the block up the inclined plane at a constant velocity. State Newton's first law in words. So Newton's first law, it states that an object will remain in its constant state of motion, or else it will remain at rest unless it is acted upon by a non-zero net force, by a non-zero net force or resultant force. So whenever we've got an object, let's say object A, if it is at rest, it will remain at rest. If it is moving at a constant motion, it will remain moving at a constant motion. Unless there is a net force, a non-zero net force that acts on that object. That is the only thing that can change the what? The state of motion of that object. That is what Newton's first law states. Now they're saying draw a labeled free body diagram of block B. So on block B, we are actually having the weight of block B. So we are going to have the weight of block B, and we are now having this force, the applied force. Since the object would go in that motion, this side would be having what? Tension on that string, and we are also going to have what? Frictional force. After having frictional force, we are also going to have a balancing normal force there. So here they gave us 5 marks. We are supposed to have five what? 5 forces. I have got 1, 2, 3, 4, and 5. So my free body diagram would actually look like this. This is the free body diagram where I've got my weight of the object B, and then I've got my applied force that is going in that direction, my applied force that is going in that direction, and then I would be having a normal force that is just balancing the perpendicular component of my weight. I would be having a normal force there. So the normal force would be Fn. And then I would have frictional force, which I would represent as what? Let me just get to say Fr to represent frictional force. And then I would also later have the tension in that is actually going to be T. So this is frictional force, and then that is tension. So I have got my 5 forces represented there. So the magnitude of F is greater than T and Fr, and it is the one that is causing it to go that side. So hence the long what? The long R. So that is how you draw your what? That is how you draw your free body diagrams. You need to represent your object with a dot, and then you need to represent the magnitude of the forces that are acting with the length of the what? With the length of the R. And then the head of that arrow points in the direction in which that force is actually what? Is actually projected to. So we are saying that this dot represents the object, and then I would represent our what? Our forces using arrows. So the length of each arrow represents the magnitude of that what? Of that force. And the arrowhead represents the direction in which the force is going. So those are our forces there. Now they are saying calculate the normal force acting on the block B. Normal force Fn would be given by Fg parallel. Fg perpendicular, which is the perpendicular component of this weight. So it will be weight cos theta, where you know that weight is given by mg, so it will be cos what? 15. So our mass of block B, so they said block B has got 8 kg. It will be 8 times 9.8 cos 15. So now, what is 8 times 9.8 cos 15? 8 times 9.8 cos 15. That would actually get to give you what? 75.73. So the normal force there was just going to be 75.73 newtons. That was the normal force there. Now let's see the following questions. Let's actually get to see the following questions. They are saying calculate the tension in the string. Calculate the tension in the string. Now to calculate the tension in the string, maybe allow me to actually get to use this side. So to calculate the tension in the string, I would come and I would need to calculate forces that are acting. I would say forces that are acting on A, and then I would need forces that are acting on what? On B. So here I'm told that the objects are moving at constant velocity, so the net force would be equal to zero. So I would say net force is equal to zero. So the net force that is acting on A, we have got this tension that is going that side. It is the one that is pulling this object up, and then because the object is going up, our frictional force will be going down, and we are told that the frictional force there is 29.8, and then we would be having the parallel weight component going down, which is Fg parallel like that. So if I balance these three, they have to be equal to zero. So I would take T to be in the positive direction, the direction in which our object is moving. So T minus Fg parallel minus, this is for object A. This is for object A, minus what? Minus Fr, frictional force on A, is equal to what? To zero. So I would say my tension there can be equal to Fg parallel on A minus the frictional force on A, where this is equal to mg sine of 15 minus what? Minus 29.88. Now the tension there would just be equal to what? So now we are saying that the tension that I would have there, I would have 10 times 9.8 sine 15 minus that 29 point what times minus 29.88. So the answer that I'm supposed to be getting there, the answer that I'm supposed to be getting is going to be equal to what? So I think at some point in time when I transposed those, I should have, here it's supposed to be plus, because I'm saying this is a negative, it goes, it becomes a positive. It's a negative, it goes, it becomes a positive. So I was just supposed to add there, because now I was seeing that if I say this minus that, the answer that I was now getting in my calculator was not logical. So that is the reason why I'm saying I should have made a mistake. So the mistake was just on this positive. So if we add there, we are now supposed to get, if I say 29.88 plus that, it is supposed to be equal to, my final answer would be something like 55.24 newtons. That becomes the tension in the string. That becomes the tension in the string. Now they are saying calculate the force applied on block B. The force applied on block B. Now to calculate the force applied on block B, since I now have got the tension, it will now be easier because I'll just get to calculate, or else I'll now get to look on the forces on what? On block B. So let me just get to pull it up. So now the forces on block B, you would see that as block B is in this format, F is going up, and then going down it will be Fg parallel of block B, and then we would also be having tension on this string, and we will also be having what? The frictional force, because this force, applied force, is the one that is causing movement upwards. So because we are saying that the net force is actually equal to 0. We are going to take this one to be positive. So FA will be balanced by this FG parallel of block B plus tension plus FR on block what? B. So FG parallel on block B, it is 8 times 9.8 sine 15. We calculated this plus the tension that we calculated, which is 55.24, plus the this one is going to be equal to 0.1. They said 0.31, sorry, times 8 times 9.8 cos 15. And then the total answer that you are supposed to find here, you are just supposed to find, if I add those, I'm going to find 91.43 newtons. So if I round off, my answer for the force applied, that is the force applied on block B, the force applied that is applied on block B is equal to 91.43. That was the answer that we were supposed to find there. Now they are saying, the force applied on B is removed. So this force that was acting up is now being removed. When it's removed, the two blocks starts to slide down. These blocks, they are now sliding down. So it simply means that now we are having FG parallel of A going down. And then if that is the case, the frictional force on A would be going up. The frictional force on A would be going up because frictional force tends to always oppose the motion of what? Of the object. And then also would have frictional force on B going up. If that is the case, here I'm also going to have FG parallel on B going down as well. And due to this string, we are going to have tension there. So in the first place, the tension due to A would be going in that direction because it would be trying to what? To actually, it would be being, A would be pulled by B. And then for B, B would be pulled by what? By A. So that is how we can use that. Now they're saying state Newton's second law of motion in words. This is Newton's second law, but they want us to state it in words. We are saying that if a net force is applied to an object, that object will start to accelerate with an acceleration that is directly proportional to this net force and inversely proportional to that mass. But it will be in the same direction as the force. So you would just come here and say what? Let me rub here so that I can write that definition here. We are saying that if, I'm sure it's easier to come from this side because we might want to use that other side. Yeah. So let's try this side. So 5.4 would be to say if a net force, if a net force is applied to an object, the object will start to accelerate in the direction of the net force applied. With a magnitude of the acceleration being directly proportional to the magnitude of the net force, but inversely proportional, to the mass of the object. That is what Newton's law states. Now they are saying, how will the frictional force experienced by block A change? The frictional force, we have removed the applied force. We were having applied force here. We have removed this force. Now they are asking, how is the frictional force that is experienced in block A going to change? So the frictional force is actually going to what? To remain the same. It will be of the same size. But now the frictional force is now acting in the opposite direction than it was acting before. That is what is going to happen. So we are going to say that let me use another pen. It will be of the same size but in the opposite direction. It will be of the same size but in the opposite direction, because friction opposes the force of motion, but friction is dependent on what? Frictional force is dependent on the coefficient of frictional force and the normal force. So here the weight did not change, the slope did not change, and the roughness does not change. So this will remain the same in terms of its magnitude. The magnitude will remain the same, but the direction is the one that is going to change. So the frictional force here is now going to be in that direction, since this object will now start what? Going down. Since that object is now going to go down, because they said the force applied on B is removed. The force applied on B is removed, and the two blocks start to slide down the inclined plane. So when they slide down the inclined plane, the frictional force would be now in the opposite direction. Now they're saying calculate the acceleration of the system. Now we need to calculate the acceleration of the system. So to calculate the acceleration of the system, I would also use the same to say I would look at forces on A. Let me look on forces on A. So net force there will now be equal to MA for object A. So I'm going to look on forces on object A. So I said on object A, I would be having the FG parallel of A going down. And then I would also have what? There is nothing else there, since I would be having what? I would be having this going down. So as this is sliding down, it will be sliding down to this parallel weight component. And then here I would have a tension due to the what? To the object B. And also I'm going to have a frictional force that is trying to oppose this motion down. So here I would be having FG parallel of A minus the tension minus the frictional force. So let me just get to say the frictional force being equal to MA. So here I would be having what? I have got 10 times 9.8 sine 15. This minus the tension minus the frictional force here, which remains the same. It will be 29.88 equal to what? To 10A. So I try to make T the subject here. That would actually be what? T is equal to, so if I say this one minus that one, I would remain with what? Negative 4 point. So you would see that if you punch in your calculators, let's punch in our calculators, we are saying 10 times 9.8 sine 15, that is 25.36 minus 29.88. That will give you negative 4. So here you'll be now having what? 10a plus 4.5. That will be 4.516. And then if I now get to look on the forces that are acting on B, so maybe let me use the forces that are acting on B here. I would say forces acting on B. The forces acting on B, I would have F net being equal to MA. So here I would be having the frictional force going up. So that would be the frictional force going up. That is opposing my FG of B parallel. And then also the tension here in the string. So I'm going to have these are positive. So this would be FG parallel of B plus T minus my frictional force there being equal to what? To 8A. Now if I substitute here, it would be 8 times 9.8 sine 15 plus T minus the frictional force here. It will be, we said it's 0.31 times, we are having what? 0.31 times 8 times 9.8 cos 15. So that one will give you a value of what? Because I just need that value. So if I say 0.31 times 9.8 times 8 cos 15, that is going to give me 23.42. So this one will be 23, 476 being equal to 8A. So that one will be equal to 8A. So maybe I was just supposed to have this coming to actually, let me just try to create space. We have already seen how those forces are acting. So I would write this one here. Now that we know, so these are forces on B. And we said due to the net force, we can be able to use we can be able to say 8 times 9.8 sine 15 plus, because that is FG parallel and T, and then we have got Fs plus tension minus Fs, and we are saying our Fs is going to be what? We are saying our Fs is going to be 23 point, that is going to be 23.476 being equal to 8A. Now I also need to make T the subject there. By making T the subject, I'm going to have T being equal to, if I say this one minus that one, I'll be left with what? Negative 3.5 something. So if I say that one, I have 8 times 9.8 sine 15. That will give me 3.81. So I would have 8A plus 3.184. So I now have got two equations, which is equation 1 and equation 2. So I will take equation 2 this side so that it becomes T is equal to 8A 8A plus 3.184. I'll now get to subtract these two equations. I'll subtract 2 from 1 so that I can have what? If I do T minus that one, I would have 0 here. And then here I would have 2A. And then here I would have, if I subtract that, I would have here I would have plus 1.33. So here I would be having what? Plus 1.332. If I take this one that other side and then later divide by 2, it would be a negative 1.33 to be a negative 1.33 2 equal to 2a. I divide by 2, I divide by 2. So if I divide by 2, I'm going to get an acceleration which is equal to 0.66 6 meters per square second. So the acceleration here would be equal to 0.666 meters per square second. That is the acceleration that you are finding there. So that is how you actually calculate your acceleration. You actually get to look on the forces that are acting on A. You apply F net is equals to ma. So you apply the Newton's second law on A, apply Newton's second law on B. Try to actually get to combine by having to collect like terms, like your tension is common in both A and B, and also the acceleration is the same in A and B. And then thereafter, you solve. By doing that, you would be able to solve and actually get what? To calculate your acceleration. After calculating your acceleration, even if they say calculate tension, you can be able to substitute that acceleration and actually have to what? To solve for your tension. If that being the case, let's look on the next question to come. So the next question is now saying, which is 5.7. 5.7 is now saying the two blocks reach a flat surface. Now the two blocks now have reached a flat surface where we have got A and B. That is what they are saying. The two blocks reach a flat surface with the same properties as the surface on the incline and continue to move on a flat surface till they finally stop. Now they are saying, how will the frictional force experienced by the blocks change on the flat surface? Explain, increase, decrease, or remain the same. The friction would increase because definitely they are coming to a stop. And also the other thing is now the slope is decreased to 0. So theta is now equal to 0. So where we are now saying that F normal, it is now equal to what? To mg cos theta, where cos theta is now just cos 0. And we know that cos 0 is 1. So this is now equal to mg times 1, which is the greatest value of cos. So we can actually get to know that the frictional force, because frictional force is actually given by the coefficient. Since they're saying the coefficient of frictional force is remaining the same, we will now bank on the normal force. So the normal force is going to increase, therefore the frictional force is also going to increase. So here you're just supposed to say the frictional force will increase. Why? The explanation is to say the normal force will increase because now we are saying that the angle, or else let's say the slope is decreased to actually what? To become 0. So the angle there has decreased to become 0. Our cos there is maximum on 0. So normal force will increase. Therefore, our frictional force will increase. So just to shorten that, someone would ask, how was I supposed to actually get to write it? Because you are just mumbling and mumbling. You are supposed to say it will increase. It increases. Why? Because the normal force will increase since the coefficient of friction, remains the same. Therefore, the frictional force will increase. The frictional force will increase because you have said the normal force will increase. Since the coefficient of frictional force is just remaining the same, so the effect of the normal force, as it increases, it will also increase the frictional force. If that is the case, that is what you are just supposed to write there. That is what you are just supposed to write there. Now, they are saying, identify a pair of Newton's third law of motion while the blocks are sliding down the inclined plane. So this would actually be block A acting on block B, as well as block B acting on what? Acting on block A. Those are the pairs to actually get what? To support Newton's third law. Now let's go to question number 6. Yo, that one was a long question. That was the longest question, and it was housing 32 marks. You have to make sure that you collect all the 32 marks. Now, a small metal sphere P is placed on an insulated stand. The sphere carries a charge of -4 nanocoulombs. This is the sphere. They say state the principle of conservation of charge. State the principle of conservation of charge. We know that charge can neither be created nor destroyed. So I can come here and say charge can neither be created nor destroyed. However, it can only be transferred. It can only be transferred. It can only be transferred from one object to another. From one object to another. From one object to another. That is the principle of conservation of charge. Calculate the number of electrons in excess on sphere P. We know that the number of excess electrons is given by N is equals to the charge divided by the charge of an electron. And we know that the charge of an electron is given by what? -1.6 times 10 to the power -19. So that is the charge of an what? Of an electron. Now we need to look at the charge of the what? The charge of the metal sphere. It is just -4 times 10 to the power -9. So you divide these, you need to find the number of electrons there being equal to, the number of electrons were now going to be equal to 2.5 times 10 to the power of 10 electrons. Those were the number of excess electrons there. That is how you would have just what? Calculated that. That is how you would have just calculated that. Now they're saying a second identical sphere Q carrying a charge of +3 nanocoulombs is placed 4 centimeters from the sphere P as shown in the diagram, which is this diagram. State the Coulomb's law in words. So we know that Coulomb's law, just get to say F is equals to K, Q1, Q2 over R squared. They want us to state it in words. We are saying that the net electrostatic force acting, or else the net electrostatic force exerted by one point charge on another, exerted by one point charge, exerted by one point charge on another is directly proportional to the product, of the 2 point charges, of the two charges. It is directly proportional to the product of the 2 point charges, and inversely proportional to the distance in between the charges. Distance in between them. That is what this law states. It says that the net electrostatic force that is exerted by each point charge on another is directly proportional to the product of these 2 point charges and inversely proportional to this square of the distance. Inversely proportional to the square of the distance. It is square of the distance between them. Now they are saying, is the force of sphere P exerted on sphere Q a force of attraction or repulsion? Let me just get to wrap this definition, and then we get to see what they mean there. Is it a force of attraction or a force of repulsion? So how do we know a force of attraction or a force of repulsion? We know that like poles they repel, like poles they repel, and then unlike poles they attract. So here we've got negative and we've got a positive. Therefore, they would what? They would attract. So the force here is force of attraction. It's force of attraction because we have got unlike poles. We know that unlike poles attract. So the force there is of attraction. Now they are saying the spheres are now brought into contact with each other and then separated to their original position. Calculate the new charge on each. So the new charge, how will you calculate the new charge? You would simply get to add sum the charges and then divide by 2. So the net individual charge would be equal to Q1 plus Q2 all divided by 2. And then we know that Q1 is given as what? Q1 is negative 4 nanocoulombs plus 3 nanocoulombs divided by 2. That is going to be equal to negative 1 nanocoulomb divided by 2. That is going to give you negative 0.5 nanocoulomb. And this can actually be represented as what? It can either be negative 0.5 times 10 to the power negative 9, or else negative 5 times 10 to the power negative 10. It's just the same thing. Now they are saying calculate the magnitude of the electrostatic force now exerted by sphere P on sphere Q. When we now have got this new charge, our F will now be equal to K Q1 Q2 all over R squared, where we know that the distance that was given there is what? 4 centimeters. So if our r is equals to 4 centimeters, we divide by 100 centimeters, and this would be equal to 0.04 meters. So I'm going to say K is just what? 9 times 10 to the power of what? 9 times 10 to the power 9. And then I would multiply by Q1, which is just what? Negative 0.5 times 10 to the power negative 9 times negative 0.5 times 10 to the power negative 9. All divided by what? 0.04 bracket squared. So I need to find the value there. What becomes the value? So the value here, the net force has to be equal to 1.41 times, it has to be 1.41 times 10. It is times 10 to the power negative 6 newtons. So that is the force, that is the magnitude of the electrostatic force there. If that is the case, now let's look at the following question. Let's look on the following question. Allow me to rub here because we've seen how we calculate those. Now let's look on the what? On the following question. Now we are saying, by what factor will the magnitude of the force in question 6.6 change if the distance between the sphere is halved? So now the distance is now a half of the what? Of the initial r. So r2 is now equal to half r1. Now they are saying do not use any calculations. We know that F is equal to K, Q1, Q2. Nothing is changing on top. Below there, that is when we are now having what? Half of that. So this factor would actually get to go to what? It would be K, Q1, Q2 all over 1 over 4 r squared. So if you invert, you would have 4 times the original force. So you would have just came here and said that it would actually get to increase 4 times. So it would be 4 times greater. So you would say it would be 4 times greater. 4 times greater. So you did not need to show any calculations. You would say 4 times what? Greater. That is how it would change there. Now let's go to question number 7. Question number 7 is saying P is a point 1.5 meters from a charged sphere Q. The electric field at P is 6.6 times 10 to the power 7 Newton per coulomb directed towards Q. So this is the electric field, which is E, given by force per unit charge. And they're saying it is directed towards Q, Refer to the diagram below. Define the term electric field at a point. This is the what? Net electrostatic force acting per unit charge. The net electrostatic force acting per unit charge, force per unit charge. That is the electric field at a point. Acting per unit charge at that point. Draw the electric field pattern caused by the charged sphere Q. Since the electric field is towards Q, we can actually get to term Q being the what? It is actually a negative. It is actually a negative. How do you draw that? You can actually have your negative being here, and then you would have your charges, the field actually what? Pointing inwards, like that. You can have your field pointing inwards like that. So this is just a sketch, guys. So you are not supposed to be very eloquent on it. You are just supposed to draw an accurate sketch, that would represent exactly what's happening. So that is how it will be. That is how you would have just drawn that diagram. That is for question number 7.2. Now they are saying calculate the magnitude of the charge on the sphere Q. The magnitude of the charge on the sphere Q. Now what we are given here, let me take this one this side. Magnitude of the what? Of the charge Q. We are given E, which is net E, that is acting on Q, where we know that this becomes EQ over R squared. And they say this is what? 6 times 10 to the power 7, being equal to K. We know that K is just what? K is just 9 times 10. K should be actually what? 9 times 10 to the power 9. And then we are looking for Q all over the distance there. It's 1.5 squared. So if you make Q the subject there, you are supposed to find what? You are supposed to find, if you make Q the subject, you are now supposed to find, let me just get to say, you were supposed to come here and say 1.5 squared times 6 times 10 to the power 7 all over 9 times 10 to the power 9. So let's try to do that. 1.5 squared times, we now have got 6 times 10, that is to the power 7, and then that is divided by 9 times 10 to the power 9. So the charge that we are supposed to find there, it was just supposed to be equal to what? 0.015. So the charge here was just supposed to be equal to 0.015, which is equal to what? You can say 1, 2, that would be 1.5 times 10 to the power of what? Negative 2 coulombs, or else it would be 15 times 10 to the power negative 3 coulombs. Whatsoever way you want to represent it with. So that was going to be the charge that you were supposed to what? To calculate there. Make sure, guys, you substitute the correct information that you are given here, which is 1.5 and 6 times 10 to the power 7, for you to get those answers. Now let's see what this question is now also saying. So allow me to just get to wrap some things here, because we've already used them. If that is the case, let's see question number 7.4. Now they're saying another charged sphere. They're saying another charged sphere R having an excess of 10 to the power 5 electrons is now placed 0.75 meters to the right of charge Q. Calculate the net electric field strength at point P. The net electric field strength at point P now. Now you can see that we know that the net electric field can be given by electric field on what? because they are saying that calculate the net electric field at point P. At point P due to Q, so that this one will be due to Q, plus at point P due to what? Due to R. Now we need to determine the directions of this. We said that this is actually what? Because here they are saying, we said this one is a negative, and then here they are saying this one is having an excess of electrons, so also this one is a negative. So the electric field due to Q would actually be towards Q, and then the electric field there, it will also be towards what? R. So the electric field is actually in the same direction, so here would actually get to add this. Now if that is the case, they are saying calculate the net electric field strength, so I need to calculate E due to Q. So E due to Q, I'm already given it's 6 times 10 to the power of 7 newtons per coulomb. And then I now need to calculate E due to R. E due to R would be K Q of R divided by what? By R squared. So the distance that is in between here, it is 1.5 plus 0.75. That would be actually what? 2.25. So this one will be squared. And then here I would be having K. So here my K, I would actually have my K there, 9 times 10 to the power 9, multiplying what is the charge on R. The charge on R, I have got number of excess electrons. I would multiply by the charge of what? Of an electron. So this will be 10 to the power 5 times 1.6 times 10 to the power of 19. That is the charge that I'm going to use there. So this would be actually what? 1.6 times 10 to the power 5 times 10 to the power negative 19. So if I do that here, I would be having a value of what? So let's see what would be that value. If I say 9 times 10 to the power of 9, and then I multiply by 1.6 times 10 to the power of 5 times 10 to the power of negative 19. That is going to be, and then if I divide by 2.25 squared, I would have my value being, I would have 2.844 times 10 to the power negative 5. So I have got 1, 2, 3, 4, 5 to the power negative 5. So that is the electric field due to what? To R. Now if that is the case, I now need to add these two. So I would come here and say E net. Now allow me to say E net, E net. So I would rub this because I've used this one. So I would say E net now will now be equal to that of EK. It's 6 times 10 to the power 7 plus 2.844 times 10 to the power negative 5. If I add these two, the value will simply come back to 6 times 10 to the power of what? To the power of 7, because this would be negligible to this. So it will just come back to this value. So it will be newtons per coulomb. So that becomes the E net. Make sure that you are substituting the correct values that are given there, and you actually get to depict it as it is given correctly, as according to this diagram. Don't actually get to start drawing your own diagrams or creating your what? Your own diagrams. Now let's go to question number 8. So we have question number 8. Question number 8 is saying a magnet is brought near a solenoid or coil as shown in the diagram below. This is the magnet that is brought this side. They're saying state the Faraday's law of electromagnetic induction. Faraday's law is given by that equation. So we know that an EMF is induced whenever there is change in what? In electromagnetic what? Flux linkage. So you would actually come and say that an EMF is induced in a conductor whenever there is change of magnetic flux linkage within that conductor, within that same conductor, within that conductor. So whenever in a conductor there is change in the magnetic flux linkage, there is going to be an induced EMF. That is what the Faraday's law states. Now they are saying, why does the galvanometer deflect as the magnet is brought closer to the coil? So when the magnet is brought closer to the coil, we are going to see that there is change of magnetic flux linkage. As the magnetic flux linkage is changing, there is an induced EMF. Hence, therefore, we are saying the galvanometer would actually get to deflect because there is, you would actually get to say, because there is induced current, because there is what? Induced current flowing. So whenever there is flow of current, the galvanometer needle would actually get what? To deflect, to actually get to show the what? The flow of that current. So the galvanometer needle, it deflects because there is induced current flowing. What rule can be used to predict the direction of the induced current? The rule that you can use to predict the induced current, it will be the right hand solenoid rule. Right hand solenoid rule. Or else you can say Lenz's rule. So the right hand solenoid rule is the one that we use to predict the what? The direction of the induced current. Now they are saying give three ways in which the strength of the induced current can be increased. So the strength of the induced current, you can actually get to what? You can increase the coils or else the turns of the solenoid or else of the conductor. And then you can also get to what? You can also get to increase the current that is flowing in the solenoid, increase the current that is flowing in the solenoid. Also, you can actually get to use a stronger magnet. You can use a stronger magnet that would provide what? A higher magnetic field. Or else you can use a soft what? A soft bar magnet material. That is, so here they said three, so these are the three. Now they are saying a coil with 200 windings, which are 200 turns, is rotated so that the magnetic flux linkage with each winding changes from 5 times 10 to the power negative 4 Weber to 1 times 10 to the power negative 4 Weber in 0.2 seconds. Calculate the induced EMF in the coil. So the induced EMF in the coil would actually be given by that equation, which says EMF is equal to negative N change in phi all over change in T. So since we would be looking for the magnitude, we just get to drop this negative and say N would actually get to say the change in phi would be determined by phi final minus phi initial. So we can say phi final minus phi initial divided by the time taken. So now we now need to actually get to take our information there. What is the number of turns that is given there? The number of turns, we can actually see that it is 200. And then what is the final phi? It is 1 times 10 to the power negative 4 minus 5 times 10 to the power negative 4 divided by what? Divided by 0.2. So if you calculate using your calculators, what becomes the EMF induced, it has to give you 0.4 volts. It has to give you 0.4 volts. So that is how you would have answered that question. Now let's go to our last and final question, which is question number 9. So question number 9 was now saying, state Ohm's law in words. State Ohm's law in words. Ohm's law can be given by I being directly proportional to V over R. So we are saying that the current that flows in a conductor, the current flowing in a conductor, is directly proportional, to the potential difference. We can say to the potential difference across that same conductor. Given that the temperature remains constant. So when you keep the temperature constant, the current that is flowing within a conductor will be directly proportional to the potential difference across that same conductor, and evenly proportional to the resistance, definitely. Now they're saying identify the resistor that is not an ohmic resistor. So from this definition, a non-ohmic resistor, it's actually a resistor that does not actually get to obey this law. So we are saying we want to find a resistor where its current would actually get to change that is against that law. So we have got diodes, we have got bulbs, where we know that a bulb, for example, as the current increases, as you increase the current that flows through it, the temperature of that bulb also it also increases. Therefore, here we can actually get to see that this symbol represents a bulb. So we would actually come and say light bulb, which is represented by the 15 ohm resistor. So they just said identify a non-ohmic resistor. So this symbol represents a light bulb. If you were having a symbol that represents a diode, you would also get to say a diode, because those, they do not obey the Ohm's law. Now we are now given that to say that give a reason for the answer to question 9.2, because we said the temperature of the bulb increases as the current is increasing. That is what we said. The temperature of the bulb increases as the current through the bulb increases. So this is against the Ohm's law. Now they are saying that from this diagram, they are now telling us that from that diagram, we need to answer the following questions. So now they're saying, with only switch 1, S1 closed, when we close this switch, calculate the total resistance of the circuit, the reading on the ammeter, the reading on the voltmeter. So now I need to go back to the information that I was given. So let me just get to clear my space here. So the information that I was given is the total EMF is 15 volts. And then we have got that circuit. Now they are saying we close this switch. When we close that switch, our current moves, or else it flows through that ammeter. It goes through that 5 ohm, 15 ohm, and then 10 ohm, and then it goes back. So the total resistance there, it will be just resistance in series. So it will be 5 ohms plus 15 ohms plus 10 ohms. So that would actually get to give you 20 ohms. That is the total resistance there. Now we are now saying, what is the reading on the ammeter? The reading on the ammeter now, from the Ohm's law, we can actually get to know that current would be given by the total voltage over the what? The total resistance. So what is the total voltage there? The total voltage, they said it's 15 volts. The total resistance, it's 20. It's what? This is 30. If you say 15 plus 5, it becomes 20, plus 10 becomes 30. So you'd come and say 30 ohms. 15 divided by 30 ohms, the current that would be read on the ammeter would simply be equal to 0.5 amps. So here it will be 0.5 amps. That is what you are supposed to calculate there. Now they are saying the reading here. So the reading here, it's on the parallel circuit. So what we are saying is, if we actually get to know the current that is passing through each, we can know the voltage that is passing through each. So by knowing the current that will pass through here, it is actually equal to what? 0.5. And then knowing the resistance there, we can actually get to say V is equals to IR. So that being that, IR, that is 0.5 amps times 10 ohms. That will give you 5 volts. That is what you are supposed to do there. That is what you are supposed to do there. If that is the case, let's look on the next following questions. Now they are saying switch S2 is now also closed, which is also this. Now we have got this switch closed, that switch closed. And then they're saying the reading on the ammeter is now 1.2 amps. What will you observe in connection with the brightness of the lamp? Choose increase, decrease, or remains the same. When we increase the current that is flowing through the circuit, that would be the current that is flowing here. We are now having 1.2 amps. We were having 0.5 amps. So you can see that the current has increased. Since the current 2 is now greater than current 1, we can say that the energy that is passing through this bulb will increase. So hence, therefore, the brightness will increase. Give a reason to your answer. We get to say that as current increases, the energy dissipated by the same bulb will also increase. So we are saying that here, as the current increases, the energy that would be dissipated would also get what? To increase. Or else the power dissipated, which is given by I squared R, where this is remaining the same, I is increasing. So the power dissipated there would also get what? To increase. Now they are saying what would be the reading on voltmeter V2? What would be the reading on voltmeter V2 if we are now having a current on 1.2 amps? So if we are now having a current of 1.2 amps, the reading on the voltmeter V2. So now we are saying this, the total voltage there is 15. So now we can calculate the voltage there, which will be 1.2 times 5 ohms. And then we can calculate here also it will be 1.2 times 15 ohms. And then if we add these ones and subtract them from here, we are supposed to get the voltage on the parallel circuit. So the voltage on the parallel circuit is going to be equal to 15 minus the voltage that is on the what? 15 ohm resist minus the voltage on the 5 ohm resist. So what is the voltage on the what? On the 15 ohm resistor, and what is the voltage that is on the 5 ohm resist? So this one will be 1.2 times 5. If you say 1.2 times 5, 1.2 times 5, it is going to give you what? 1.2 times 5, it is going to give you 6. So this one would be 6 volts. And then if you say here, it is 1.2 times 15, it is going to give you what? 1.2 times 15, it is going to give you 18. So logically, you can see that the total voltage that we are having is actually now more than the one that is coming from what? From our bat. Because here we now have got a voltage of 18 volts. Here we've got a voltage of what? 6 volts. So this is not logical. So definitely, I think at some point in time they made a mistake with this current. They should have given something that is not equal to 1.2, maybe less than, because here now we have actually what? We have overpassed the what? The voltage that is being supplied by the what? By the cell. So actually this question actually goes to be wrong. We can't calculate that voltage, because now we would say 15 minus 18 minus what? Minus 6, and then we'll get a negative voltage. There is no such thing. As well as the value of R, we can't calculate it. So I'm sure this question was actually having an error on this current value, because if we have that current value, then our voltage would actually be more than the voltage that is coming from the bat. So That was the end of our question paper. Thank you so much, guys, for being together. Let's continue practicing. Let's continue revising and actually preparing for our final exams. We actually get to say from math zone, we get to say more light and more winning. Let's continue to shine. So until we meet again, let's meet on our next videos. I say thank you.